YouTube channel. Today we are talking about graph terminology. Okay, now let's see what is graph. Graph is a non-linear data structure that consists of vertices connected by edges. It is used to represent relationships between objects such as social networks, computer networks, and transportation systems. A graph is a non-linear data structure that consists of vectors, vertices, vertices connected by edges. It is used to represent relationships between objects such as networks, computer networks, and transportation systems. Types of graphs. First type is undirected graph and directed graph. Undirected graph, the edges have no direction. If there is an edge between A and B, it means A is connected to B and B is connected to A. Example, a friendship network where relationships are mutual. Directed graph, the edge, edge have a direction represented with arrows. If there is an edge from A to B, it means A is connected to B but not necessarily to B to A. As an example, Twitter follow system where A follows B but B may not follow A. Second type is weighted and unweighted graphs. Unweighted graphs, all edges have the same weight or no weight. Example, friendship graphs where each connect is just a link. Weighted graph, each edge has an associated weight, cost, distance, time, etc. As an example, road network where the weight represents distance or travel time. Okay, now you can see vertices and edges. This is a graph main two parts. Vertices and edges. Vertex is points, the points in the graph also called as nodes. Edges, the lines connecting the vertices. You can see that picture has node and edges. Degree of vertex. Degree is number of edges connected to the vertex. In degree, number of incoming edges or directed graphs. Out degree, number of outgoing edges for directed graphs. Path, walk, and trail and circuit. Walk is a sequence of vertices where each adjacent pair is connected by an edge. Trail, a walk where no edge is repeated. Path, a trail where no vertex is repeated. Circuit, cycle is undirected groups. Undirected group. A trail starts and ends at the same vertex. This picture walk is ADE. Trail is ABFHEBAD. And circuit is ABEH. Path is HEBFHDA. Connected and disconnected graphs. Connected graph. Every vertex has a path to every other vertex. disconnected graph. Some vertices don't have a path to others. Components separate connected parts of a disconnected graph. Cycles and acyclic graphs and DAGs. Cycle. A path where a starting and ending vertex is the same. A cyclic graph. A graph with no cycles. Directed acyclic graph. A directed graph with no cycles used in schedule dependency resolution. This picture you can see a directed acyclic graph. It connects each nodes and edges. Special types of graphs. Complete graph is the first special type of graph. Every pair of distant vertices is connected by an edge. As an example, a fully connected network where everyone knows each other. Bipartite graph, the vertices can be divided into two sets such that edges only connect vertices from different sets. As an example, job assessment problem where workers are connected to task. Third type, multigraph, a graph that allows multiple edges between the same pair of vertices. As an example, railway networks where multiple tracks exit between two vertices. As an example, railway networks where multiple tracks exit between two stations. Okay, now I think you can understand what is graph, type of graph, special types of graphs, and what is walk, trail, path, circuit, and what is mean graph, edges, nodes, means. I think now you can understand the graph terminology. Okay, now I'm going to finish. Bye. See you next time.